Welcome to a lesson on determining the value of an annuity. The goals of this video are to define an annuity and then determine the value of an annuity. An annuity is a sequence of equal payments made at equal time intervals. For example, an IRA or individual retirement account is an account where you may make deposits on a monthly basis in order to accumulate enough money to retire on. The value of an annuity is the sum of all of the deposits with all the interest earned. Now, this video will only address ordinary annuities when the payments are made at the end of each period. If payments are made at the beginning of each period, the formula would be different and is called an annuity due. Before we look at an example, let's review the three basic formulas used to calculate interest. For simple interest, interest is paid once per year. For compounded interest, the interest is paid n times per year. So if it's compounded monthly, n would be 12. Quarterly, n would be 4, and so on. And then for continuous interest, interest is paid continuously. Let's take a look at a basic example before we take a look at the formula used to determine the value of an annuity. Let's say you deposit $500 at the end of each year for 3 years into an annuity that pays 5% annual simple interest. What is the value at the end of 3 years? As we're making the deposits at the end of the year, at the end of the first year, we would make our first deposit of $500, so the value would just be $500. Now, at the end of the second year, we would earn interest on the first $500 and then add another $500 to the balance. So we'd have $500 from the first year times 1 plus 0.05 using the simple interest formula where t would be equal to 1 plus the new deposit of $500. Let's see what the new balance would be. We have 500 times, this will be 1.05, plus the new deposit of $500 at the end of year 2. So we have $1,025. Now throughout year 3, the $1,025 earns simple interest at 5%. And then at the end of the year, we make another deposit of $500. This would be the value of the annuity at the end of 3 years, given we use 5% simple interest, with deposits at the end of each year. So we have $1,756.25. So from this example, you can see the pattern that is developing. However, if we were compounding interest monthly with monthly deposits, you can see this method would be very time-consuming. So there is a formula that we can use to determine the value of an annuity based upon the number of compounds per year and the number of deposits per year. And here it is. So R would be the annual nominal interest rate, T would be the number of years, N is the number of compounds per year, P is the amount of each deposit, and A would be the value of the annuity. And if we were dealing with simple interest, N would be equal to 1. Let's go and take a look at a couple of examples. At age 30, you deposit $150 at the end of each month into an IRA that pays 4% interest compounded monthly. At the age of 65, what will the value of the annuity be, and how much interest did you earn? So this would be a good example of if you start saving early, would saving $150 a month be enough to retire on? Let's see if we can determine all of the values here in the formula. So the value of the annuity is going to be equal to P, which is our monthly deposit, times the quantity 1 plus the rate expressed as a decimal, that'll be 0.04, divided by N, the number of compounds per year. It's monthly, so N is 12. And raise this to the power of N times T, where N is the number of compounds, that's 12 per year, and T is the number of years. Well, from 30 to 65, that'll be 35 years. Minus 1, there's our numerator. I'm going to divide this by R divided by N, where R is 0.04 and N would be 12. So from here, we'll go to the calculator. We'll start with a parenthesis for the numerator. have 150, and then we'll have two open parentheses, 1 plus 0.04 divided by 12, and raise this to the power of 12 times 35, minus 1, and then a closed parenthesis for our numerator. Then we'll divide this by a denominator of 0.04 divided by 12. $137,059 and approximately 64 cents. Now the second question asks us, how much interest did we earn? Well, this is the balance of the account, but to figure out how much interest we earned, we have to determine how much money we actually deposited into the account. We can do that pretty easily. We deposited $150 times 12 for each year, and then we deposited this for 35 years, so multiply this by 35. That'll tell us the total amount of our deposits. We deposited a total of $63,000 into this annuity. So if we take the balance of the account and we subtract our deposits, this will give us the total interest earned. And that's just going to give us $74,059.64. Now for the second example, we're going to look at the same situation, except instead of starting at age 30, what happens if you start at age 40? How will that change the balance as well as the amount of interest earned? So the formula will look almost exactly the same, except now t is going to be 25 instead of 35 because we're starting to save 10 years later. So our exponent here is going to be 12 times 25 instead of 12 times 35. The interest is the same as well as being compounded monthly. So let's see what this would give us. So we'll go through the same process in our calculator. Just remember we need another set of parentheses for the numerator and denominator to keep everything straight. So now notice the balance dropped considerably. Now it's only $77,119 and approximately 43 cents. So let's go ahead and determine the total interest earned. So the total amount deposited would be $150 per month, so times 12 for 25 years. 150 times 12 times 25 is equal to $45,000. This is the total amount deposited over the 25 years. So if we take the balance and subtract out the amount that we deposited, that'll tell us the total interest earned. We're going to have $32,119.43. So again, if we say for 25 years, we have a balance of approximately $77,000. We've earned about $32,000 of interest. But if we start just 10 years earlier, we have a much larger balance in the account of approximately $137,000, and we more than double the amount of interest earned. So I guess that tells us that if it's possible, we should start saving for retirement as soon as we can. I hope you found this helpful. In part 2, we'll take a look at how we can determine these values very quickly on the TI-84 graphing calculator.